This video, we're going to talk a little bit about what it means to solve a right triangle. So this is something that you'll definitely do in your trig course once you have all the tools in place in order to do this pretty efficiently. Solving a right triangle basically just means you're looking to determine any of the missing angles and any of the missing sides. So by the end of the problem, you're going to have 6 things total in place, all 3 angle measures, all 3 side measures. Now, one thing that I see people get confused about whenever we first start solving right triangles is they assume that every problem is just like the one they just completed. And that's definitely not the case. There are a lot of different things you can do in order to help along the way when you're looking to solve a right triangle. There are 2 things that you've spoken about prior to a trig class, and that would be the Pythagorean theorem. If it's a right triangle, you have the opportunity to use that. The only issue with the Pythagorean theorem is you need to know 2 of the 3 sides. What if you're only given one of the 3? Then you can't use that right away in order to find the missing side. You might have to do something else before you open up the door to use that option. All of the angles of a right triangle, of any triangle, it doesn't have to be a right triangle, all of the interior angles of a triangle have to sum to 180 degrees. So if it's a right triangle, you know you have a 90-degree angle. Let's say neither of the other angles are specified. If you don't know 2 of the 3 angles, of the triangle, you're not going to be able to use that option right away. Usually these options are nice to finish the problem. Like once you find one of the 2 missing sides, you can use the Pythagorean theorem to find the third. Once you find one of the 2 missing angles, you can use the sum of the interior angles to find the third. The other options that are on the table, and these are the things that are a little bit more advanced, would be to use the normal trig functions, sine, cosine, and tangent, SOHCAHTOA. That would help you find missing sides. If you need to find missing angles and you have more than one of the angles missing, inverse trig can also be used to help you do that. So we'll go ahead and we'll look at this example. Like I just said, don't assume that every problem you're going to see, though, is exactly like the one that we're about to complete. These are all of the options. As you start to solve the problem you're working on, you might open up the opportunity to use some options that you think are simpler than some of the ones that are a little bit tougher. If you'd rather use some of the tougher options, SOHCAHTOA, inverse trig to find everything, that'll work too. A lot of different ways you can do this sort of problem. So if you look at the one that we have right here, we've got the triangle, and this is the generic right triangle that pretty much any trigonometry textbook would present. They've got the angles, they've got the sides represented by the lowercase letters A, B, and C, and then the angle that's opposite of each side is represented with the corresponding capital letter. So the angle opposite capital, lowercase a rather, is represented by capital A. The angle that's opposite lowercase c is represented by capital C, and then the angle that's opposite lowercase b is represented by capital B. So what we are given within this particular problem is that angle A is 33 degrees. So you see I've already labeled that, right? So angle A is 33 degrees. Side B is 5.8 degrees. So I'm going to get rid of some of my highlighting here, and we'll just try to make sure we're only highlighting the portions of this that represent our answer. So these portions are given, and we've already got this angle here. That's clearly a 90-degree angle. So we have 3 of the 6 pieces of this triangle already in place. It's on us to try to figure out the remaining pieces. So there's one thing that's really simple to do to find this missing angle. We talked about this right before we clicked ahead to this example. In this case, I know a 33-degree angle, a 90-degree angle. Whatever I add on to 33 plus 90 has to get me up to 180. So if I started with 180 and I just subtracted off 33 degrees, subtracted off 90 more degrees, that's going to leave me with 57 degrees sitting right there. If I didn't already know 2 of the 3 angles, I wouldn't have been able to do that, and I would have had to maybe set up a SOHCAHTOA problem and use some inverse trig to find that missing angle. You very well might encounter a problem where that is something you do early in the process. That wasn't the case for us. So we've got, 4 of the 6 pieces now, right? We've now got a missing angle. Now we've got to find these missing sides. Doesn't matter which order you find them in, you're going to have to eventually find everything. For sides, I think the easiest thing to do would be to use the Pythagorean theorem. I know this 5.8 measure. I don't know C. I don't yet know A. So I'm going to have to figure out which of these two that I want to find first. I'm not going to be able to find them both simultaneously. I'm going to have to find one of side A or side C and then do something different to find the other. So I'm going to start by finding side A. Again, I do not have to do this. I can find side C first and then find side A after that. Many ways to get everything into place properly. You've got a bunch of options. Use what makes the most sense to you. I just went ahead and chose to find side A first. So I knew this angle down here was 33 degrees. I know that this side A is opposite that 33-degree angle. And then I know this side down here that I'm given is adjacent to the 33-degree angle, right? So if I'm looking at developing a relationship between angle A, side A, and side B, relative to angle A, side A is opposite and side B is adjacent. So which of the pieces from SOHCAHTOA involve opposite and adjacent? It would be the tangent ratio. So tangent of the angle that we were looking at, which is measuring 33 degrees, has to equal opposite. Well, opposite we don't know. Opposite is A divided by hypotenuse, which is, excuse me, not hypotenuse, I'm sorry, divided by adjacent, right? Tangent is opposite divided by adjacent, which measures 5.8 units. This equation right here is easy to solve for A. I just have to multiply the left-hand side by 5.8, right? Multiplying both sides by 5.8 isolates the A. So after I multiply the left side of this equation by 5.8, I have 5.8 times tangent of 33 degrees. One other mistake that I see made at a point like this is not typing it into the calculator the right way. You'd have to double check your mode. So right now we're looking to measure angles in degrees since that's the way this problem is presented to us. So I just double check the mode. I'm in degree mode. I'm going to type in 5.8 times just the exact same thing that you see written right here, 33 degrees. And that'll give me that answer of 3.76, which I rounded to the nearest tenth, 3.8. That is acceptable. This is not acceptable. Check out what I see people do this from time to time. They especially do this whenever this 5.8 is a nicer value. They think, well, 33 is a number, so I can multiply 33 together with that 5.8. And that definitely does not give us the proper value. So when you have something that's inside of a trig ratio, as 33 degrees is, you can't multiply that together with something that's not inside that ratio from the onset, and this 5.8 is not. So it has to go into the calculator as 5.8 times tangent of 33 degrees. That gives you 3.8 units for side A. I now know that this is 3.8 units. I already knew this was 5.8 units. I know two of the three sides of the right triangle. I've now opened up for the opportunity for me to use the Pythagorean theorem to find side C. So I did the old a squared plus b squared equals c squared. Broke out the calculator. I had to take the square root of this addition in order to get the answer for C, which again, I rounded to the nearest tenth, and I got 6.9 for that. Could I have set up another SOHCAHTOA equation and solved it to find side C? Yeah, for sure. Pay attention to what your teacher's asking you to do. If they're saying just to solve the right triangle, and most trig textbooks are this way, you've got a bunch of options, right? That can be overwhelming, but as long as you're remembering what these options are and using them appropriately on your way throughout a problem, should be in pretty good shape. So once again, solving a right triangle, you're finding everything that's missing. And for this one, we had the three pieces that were given to us. We found that missing angle. We found this missing side. We found the third missing side. We've now solved that right triangle.